Today's paper is Low Overhead Asynchronous Checkpointing in Main Memory Database Systems. It's a 2016 paper. This paper presents checkpointing asynchronously using logical consistency, or calc in short, a lightweight asynchronous technique for capturing database snapshots that does not require a physical point of consistency to create a checkpoint and avoids conspicuous latency spikes incurred by other database snapshotting schemes. The experiments show that calc can capture frequent checkpoints across a variety of transactional workloads with extremely small cost to transactional throughput and low additional memory usage compared to other state-of-the-art checkpointing systems. To evaluate the calc algorithm side by side with other state-of-the-art checkpointing approaches, they implemented a memory resident key value store with full transactional support. Transactions in their systems are implemented as C++ stored procedures and are executed by a pool of worker threads using a pessimistic concurrency control protocol to ensure serializability. They run their experiments using two benchmarking applications. The first is a micro benchmark, which operates on a collection of 20 million records, where each record is 100 bytes and has a 8-byte key. The second is TPCC, which they implemented by writing stored procedures in C++. In order to compare the performance of calc under different transactional throughputs and contention rates, they implemented two different versions of checkpointing scheme. The first, labeled calc, is rudimentary version of the algorithm. The second, labeled pcalc, is a version of their algorithm that captures partial checkpoints. They compared the performance of calc and pcalc to 4 other comparison points. First, native snapshot, second, fuzzy checkpointing, third, ping pong, and fourth, zigzag. Now, let's look at the contributions. The paper has presented calc and pcalc novel methods for asynchronous checkpointing that require minimum additional memory usage, no physical point of consistency in the application state, and extremely low runtime overhead. Their experiments show that calc and pcalc have an overhead that is 2 to 10 times less than the alternative approaches, even promising approaches that were introduced recently. Furthermore, it avoids the temporary latency spikes that are common in other checkpointing approaches. Now let's give this paper a PS score. Overall, it's a nice read, so it gets 8 out of 10 on readability. With 13 pages long, it scores 8 out of 10 on length. Reproducibility and repeatability might be challenging, so it gets 6 out of 10. Industry value and learning meter is high, so it gets 9 out of 10 on each. Overall PS score is 8 out of 10.